FRQ1 and 2 with you. I'm also recording it. So please be ready to go. I'm going to be giving you so much good information, plus doing 2 homework pages with you in class. Tomorrow we'll do FRQ3 and 4. And like I said, this is not, I mean, I know that you'd rather me just leave you alone and let you work on your own most of the time, but I'm doing these with you for a reason. Like, obviously I like to teach, but it's an easier day for me too when I just let you guys do stuff. So please just know I'm doing this in every single class. It's kind of a lot of me talking and going over. All I ask for you guys to do is to please stay with me, pay attention, don't put your head down, don't work on something else. If I'm spending the time to really do this with you guys, it's because it's important, okay? So I'll get to that in a second. Just as a reminder, the mock exam is this Friday. If you still haven't signed up, feel free to walk on over there and sign up. You can still sign up tomorrow as well. If you don't sign up and for some reason that day you're like, oh, the thing I thought I had to do, I don't have to do anymore, just show up, okay? We ordered like $400 worth of food, so we will have enough food. I'm making a folder for every single one of my students, so even if you didn't sign up, show up, please, because it will be better for you, and you're going to see why. I know I've given you lots of information about that day, some of the highlights. If you're driving or getting dropped off front of the school, okay, come through the front doors. We'll be eating in the concourse 7:30 to 7:50. If you don't want to come for breakfast, that's totally fine. It's optional. Please be here between 7:50 and at the latest 8, because I want to start at 8. And my group will be going into the media center, okay? So if you have friends or siblings that are in Calc A, B, BC, or statistics, they're all invited. I don't know if they're coming, but everyone's coming, and the times are all the same. So you can ride with people from the other classes or something if you wanted to. I thought I'd mention that. And but when it comes time for 8 o'clock for us to start, I'm taking the pre-calc kids in the media center. So that's where we will be. I will have pencils for you and a calculator for you, but I'm begging you to bring your own calculator. If you have one, bring it. Charge. If you check one out, bring it, because I only have 90. I have about 100 calculators because people check them out, you know, so please bring those if you have them. And if you'd rather write with pen, bring your own writing utensils. You can write on the actual day, blue ink, black ink, or pencil for any of the parts, okay? So if you want to bring, I mean, I'll have pencils. I don't have 130 pencils. So if most of you can bring your own writing utensils, that helps, but I will have stuff if you end up not bringing it. If you're like a coffee drinker or something, maybe you want to bring coffee, because we'll have drinks and stuff, but I don't think we're doing coffee. So if you want to bring your own, like, whatever, feel free. But even though there's a ton of stuff I keep telling you, talking to you about, I did send an email to your Focus email account. So if you haven't seen it, it's because you haven't gone into Focus, but there is a message in there from me that really details everything. I sent it to you and your parents. So if like Thursday night you're like, oh my gosh, I forgot, what time am I supposed to be there, or what do I have to bring, or where do I park, it's all in that email. So just know that you could go to that email from me in Focus and see that information. Good, everybody? Yeah? Okay, so on the AP exam, you have 4 FRQs. Each are worth 6 points. You get 15 minutes for each. We're going to do the first 2, which are the 2 calculator ones. FRQ1, FRQ2, each 15 minutes, each calculator allowed. You do them in 1 30-minute period. So you can split it up however you want to. Yes? Well, it just depends. Remember, these are the points. So I'm going to kind of be talking about that. 24. Yeah. If you got all 24 points on the FRQs, that would be a 3. That would be 0 right on the multiple choice. Yeah. I mean, it's a numbers game. So there's 64 points on the AP exam. 28 plus 12, 40 multiple choice, 24 FRQ. Okay. It is not hard to get a 3. Okay, we're not shooting for 3s. I know my students can get 3s. You can. And I really kind of expect most of you to get a 3 or above. I really do. Unless you just aren't going to bother or show up or try. I'm trying to shoot for 4s and 5s for you. Here's why. And Dan, I knew I had to finish my conversation with you that you just asked me. I didn't mean to blow you off. when you are wanting to know, what is this going to do for me, besides looking good on your transcript and everything like that, and showing how hard you worked all year on this one big test, yes, you can get college credit. What college credit depends on the school. So my advice to you is, if you know, I'm going to UCF, USF, or FSU, like whatever schools that you know, or you're just curious, start looking, go to their admissions page on their website and see what they offer for all their AP classes. Because most colleges, a lot of colleges vary. All of our state colleges, USF, UCF, all of them offer the same thing. I don't know off the top of my head. I'm sorry, I should know. We'll get to that another time. But if you are dying to know now, you can look it up. But most schools that I've noticed will give you some credit for a 3 and then something else more if you get a 4 or a 5. I've also seen some colleges that give something for a 3 or a 4, something more for a 5. Okay, so I don't have time to really go deep into that right now, but if you're wanting to know, you can start looking at your individual colleges. College Board, the website, has a list of schools. You can like search by like state and stuff or name of the school, and it will tell you. It's not very updated for pre-calc because it's such a new test. This is only its second year, so colleges are still like, they haven't, it's not been reported to College Board. So I wouldn't trust College Board's site for this class, but the ones that have been around a while, like world history, U.S. history, you can totally go to the College Board website and find that out. Okay, so let's see. I'm not saying this to brag. I'm saying this because it's a fact. 187,000 students took this test last year, okay? Less than 300 teachers graded it. I was one of those teachers. It was HELL week for me. I hated it. But when it was over, I was really glad I did it. I learned a lot, and I did it so I could be a better teacher to future students. Truthfully, that's just the truth. I'm being honest with you. That's why I did it, okay? I'm doing it again because it was such a worthwhile experience. But what the benefit of that is I sat for 8 hours a day, literally, 8 straight days, no days off, grading FRQs, okay? And what that did for me is it taught me what to teach to you. I'm going to tell you, guys, I'm going to tell you, this will get you the point, this won't get you the point. Don't bother writing that, it's unnecessary. Make sure you include this word, this question, this number, this letter. You have to use this word, that's how you get the point. I have all the insider information, and it's not cheating. I'm allowed to share it with you. It's the benefit of being one of the people that graded the test. FRQ1 is my test. This is the one I graded most, and then FRQ2. I think every single one of my students should be, this is not the same question, so if you're confused by that, sorry about that. Every single one of my students should be able to get a 6 out of 6 on FRQ1, okay? And let's talk about it, okay? FRQ1, calculator, it's got 6 questions, each are worth a point, okay? You will always be given a table of values and some function. So f of x and g of x, 2 different functions. Will they always be called f of x and g of x? I think so, but don't overthink it. H of x, j of x, 2 different equations, okay? Will the second one always be a log? Nope. It could be x, it could be all different ones. And before May 13th, which is the day of the test, we'll end up doing 4 FRQ1s together. This is 1 mock exam on Friday, 2 more, and whatever. So here's the thing. That's the only difference in FRQ1 to FRQ1 to that FRQ1 to 10 more is just that the questions are the same. No different. So even though you're looking at this now like, I don't remember this stuff, you will, because I'm going to go over it with you and you're going to be like, oh, that's that easy one. I just do this, okay? So let's start. First thing is function h. What's h? She said there was only going to be f of x and g of x. Okay, in A1, they're going to introduce another equation. It's defined, h of x, by g of f of x, g of f of x. These 2 things say the same thing. You can use either one. They want us to find h of 4 as a decimal, or say it's not defined, like if there is none, and show the work that leads to your answer. All this is saying, guys, is this composition. Stuff we haven't done in a while, but I can tell you when I went over a lot of this first and second, they're like, oh yeah, because you just haven't done it in a while. This is g of f of x. Remember, this is where you start on the right and work to the left. Remember, anytime you see a number in that little parentheses, that's your input, in this case, x. Okay, so all we're doing is pick whichever one of these you like. It doesn't matter, they mean the same thing. We're going to find g, that's a parentheses, of f of 4 okay? So whatever the x value they gave you, we're going to find h of 4 by plugging that 4 into this, okay? So you're going to find f of 4, then you're going to plug it into g, right to left. So f is this function, table of values. X is 4. What is f of 4 then? 2. When x is 4, y is 2. F of 4 equals 2, right? So this equals 2. So now I have g of 2. So now I'm going to put 2 in the g function. Here it is. So this is the amount of work they want you to show. They're just wanting to see you like are plugging it into the right places. But after that, it's just putting it in your calculator, okay? So the work that leads to your answer, what I just did there, that's the amount of work. The next step is your calculator, rounding, and you're done, okay? Now understand, for time and paper's sake, we're writing like in the margins. You'll see me write down here or whatever. When you actually do the mock exam and the actual exam, you'll have a page that looks like this, and you won't write on it. This will actually be on the computer for the actual AP exam. But on Friday, it'll just be on a piece of paper. You can write on it or not, it's yours. But you'll have like a workbook, and it'll say like A1 with a box, then A2. So you'll put all this work in the box labeled A1, okay? But we're just writing wherever right now. Okay, calculator. I would go ahead and clear your RAM right now because last period was working in here, doing all kinds of stuff. Okay, so I have to type that in my calculator, and it's been a long time since we had to type logs with bases in. Anybody remember? So we're going to start by putting in 3, and I had to put log base 5 in. Does anybody remember where it is? Math, alpha, math. How are you going to remember that? Well, you're a crazy teacher. Like, I'm going to look real crazy on the day of the AP exam because as they're checking you into the gym, I can only be on the outside cheering you on. I'll be there like hugging and smiling and clapping. But I'll be yelling crazy stuff to you like, math, alpha, math for log, change of decimal to fraction, math. I'll be yelling stuff at you as you go in to like last minute stuff. Okay, math, alpha, math. But the point is you have to know how to use the calculator. No one can help you. You can't raise your hand and ask Mr. Young how to put logs in. Even if he knew how, which he doesn't, he couldn't help you. Okay? He did last year. He was one. We have such a big group. We have one of the biggest groups. We have like 4 proctors. Like Dr. Denman did it last year. Mr. Young. I don't know who's doing it this year. We have to sign up for proctoring. All right. There's my answer. How do I know what to round to? It doesn't say in the question, do I get to pick? No, your teacher has been telling you all year to round to how many places? 3. Okay? So that's a point right there. Jaden? So you'll see this again on Friday. It will be this exact same question, these exact same steps. Different plug-in probably, different equation definitely, but that's what you will do for any FRQ1A1. On A1. All right, next one. What does that symbol mean, that little -1? That's inverse. That means inverse. If you remember, inverse simply means switch x and y. Normally, like when you see f of 2, that's x, right? So when you see that symbol, what do you think the 2 actually is? Y. So it's saying, what is x when y is 2? Make sure you go to the correct equation. This is labeled f. We go to the f function. So when y is 2, x is 4. Is this a coincidence that it happened to be the same ordered pair? Yes, it doesn't. It's not always going to be. Just look at it. So this means I'm looking at y is 2, x is 4. So all you have to write, and I would just write that again, 4. That's a point. Like that took you 5 seconds if you knew how to read it. And now you do. That is exactly what you're going to see on Friday, just a different table of values. Now you know you're going to get that point, right? Like it's not hard. There are times that this is hard, and I'll tell you when we get to those. Okay? Next one, find all the real zeros of g of x. G of x, so we're talking about this one, and we're asking for the zeros. What the heck? I don't remember all these words, right? That's what we're reviewing. As decimal approximations, or say there are none. Okay, zeros are your x-intercepts, your solutions. Like if you solve an equation for x, those are called zeros. But think about it. On a graph, if you have a point on the x-intercept, on the x-axis, what all of those points have in common in their ordered pair is that y is 0. So it's basically saying when g of x is 0, what is x? So I'm just going to come down here. I'm going to show you how to do it by hand, and I'm going to show you how to do it on your calculator. So just solve the equation. That's what that means. Find the real zeros, solve the equation. Okay, so what I want to do is get my log by itself. So I'm going to divide both sides by 3. And you do not have to show any work for this, by the way, so you could skip any steps. I would have log base 5 of x equals 0. And the way we solved log equations is by rewriting them in their other form. 5 to the 0 equals x. 5 to the 0 equals x. X, whether you use your calculator or you just know anything to the 0 power is 1, answer is 1. Now that's showing the work. That's like doing it by hand. And I wanted to go over that just in case you had logs in multiple choice. Nice way for me to review. But remember, this is a calculator active problem, a question. You can go to your calculator and find your zeros without doing any work. Let me remind you. If you go up to y equals and type the equation in, 3 math alpha math 5x. Okay, so I just typed it right in there and I graph it. I want the zeros, the x-intercepts. Guys, look, look, look. If I go to second calc, we've done intersect a million times, mins, maxes, zeros. It said find the zeros. There's the word, the same word. Enter. And then you want to do left bound, right bound. Right? Just like we do all the time. See, I just moved my cursor. I could find my cursor. Left bound, yeah, I'm to the left of the 0. Arrow over to the right of the 0. Guess? Yes, please. X equals 1 when y is 0. So there's a way of doing it on your calculator. You can do it either way. There's no work needed for that problem. It didn't say anything about show computations. So you could have absolutely done your calculator. Guys, that is easy. That is an easy point for you to get. Okay? Next one, end behavior. You've done end behavior so many times, you guys. End behavior of g. Okay, so we're talking about the one we just put in our calculator. There it is. We're talking about this function. End behavior as x increases without bound. Express your answer using the mathematical notation of a limit. So, when we graded this last summer, it broke my heart. Well, when I graded it, it broke my heart that I could tell, I could see my students in the ones I was grading. I could tell they know what a limit is. They just got confused on the order of how to write it. So now I know, now you know, how to get this point is to know how to properly write a limit statement. So let's review that. LIM of the function. They pick g, so that's what we're going to put. Limit of g of x as x approaches. And then this could say increases without bound, decreases without bound. Increases without bound means towards infinity. Without bound means without stopping, right? Infinity goes to the right, increasing without any boundary cutting it off. That's what that means. That has to be there and the right answer for you to get that 1 point. There's no partial credit exactly. There is a little bit of partial credit with some of the rounding, but I'll talk about that another day. So if you messed up the order of this, like we saw this a lot, it made me think some teachers are teaching it wrong. We saw that a lot. I couldn't give you the point. Like that tells me you know what you're doing, like you know the answer, but because it's written in the wrong order, we couldn't give the point. So it has to be written correctly, and then we have to say the right answer. Again, it's graphing calculator active. I don't have to make a guess. Look at it. As my x's go to the right, meaning increasing, what are the y values doing? So x approaches, that's telling us what the x's are doing. After the equal sign, what are the y values doing? So as x increases, what are the y's doing? Increasing as well towards infinity. So you have to have all of that in that order to get the point. Okay? What we... Yeah, if it was decreasing or if it was going down, you would put negative infinity. Yeah. What we saw last summer, which I don't think we'll see too much, is people would do both sides because you guys are used to doing end behavior limits, the left and the right. What's happening on the left side, what's happening on the right side. If you accidentally do that, I just want to say it real quick, if you did the other one as x approaches negative infinity, we would give you the point for this one as long as both of them were right. So let's just not do both. You already know this question, this section of this question is going to ask for one limit statement. Just do that one. Don't do more. You don't need to. Okay? Next one. Use the table of values of f of x to determine if this is a linear, quadratic, exponential, or log function. It's got to be one of those four. All we have to do for C1 is write one word, linear, quadratic, exponential, or log, and then part 2 is describing why, okay? I'm going to go deeper into this another day. For time's sake, I'm not going to go through all of them, but here's what we're looking for, okay? We need to talk about the X's and the Y's. The inputs and the outputs are what I like to use, okay? Inputs, outputs. We have to say what's happening in both of them. So looking at my X's, I'm increasing by 2, right? We're adding 2 the whole way down, all right? That will happen in 3 of those 4. You should see that for linear, quadratic, and exponential. You should see adding the same number. It doesn't have to be 2, but it has to be a constant, okay? So that will happen in 3 of them, all but log. Now, what differentiates those 3, not the log, is what's happening with the Y's. If we were adding the same number, that would be linear, right? Adding the same number, that'd be linear. We are multiplying. This is exponential, okay? Quadratic, I will cover another day. I don't know if that's the one on your mock. Do the best you can. It's not that big of a deal. It's 1 point. If you don't get it right, or you can look it up between now and then. I just don't have time right now. Maybe I'll try. I wrote myself a note to talk about quadratic. I want to go through all 4 of them with you. But like I said, 3 of them have the same thing happening with the X. We just talked about what would happen linear, adding the same number, and then exponential is multiplying the same number. What log is, log and exponential are the same thing, but flipped. So if it was a log, it's the X's are multiplying by the same number, and the Y's are increasing by the same number, adding. So how do we write that? Well, this is just that 1 point, exponential. Just writing that one word for C1, that's 1 point. Just knowing which one it is. Part 2 is to give a reason. This is very specific, okay? I'm going to come down here so I don't run out of room. We have to talk about the inputs and the outputs. Order doesn't matter, spelling doesn't matter, grammar doesn't matter. There's a few words that are what the graders are going to look for. So you can talk about input or output first, it doesn't matter. Input values are increasing, right? They're getting bigger. If they were decreasing, getting smaller, I'd write decreasing. At equal length intervals. That's going to be like your first sentence for 3 of the 4 types. Memorize it. Input values are increasing at equal length intervals. Now let's talk about the output values. Output values, the Y's, change. This is the key word for exponential, this word. Proportionally. That is the word we're going to use for proportional, for exponential. Memorize it. We pray we get an exponential one because we just talked about it so much, but we're going to talk about that part of this FRQ more in depth another day. I'll go through all the 4 types of how you would word it. The only difference for a log is flip this. Input values change proportionately. Output values are increasing at equal. That's the only difference. Exponentials and logs are just inverses of each other. Okay, so that kind of covered log and exponential. All right, so this is the one you'll probably spend the most time on because you're going to feel the most comfortable with it. You're not as tired. It's your first FRQ. FRQ4 got left blank a lot last year. A lot of people got tired, but we'll talk about that more later. Let's go to FRQ2. Our second of 2 calculator active. Now remember, like I said, you're going to have access to question 1 and 2 in 30 minutes. You have to be smart about, oh my gosh, I just spent 29 minutes on FRQ1, now I don't get to do FRQ2. So be careful, but I'm going to give you some tricks to help you with that, if I have time today, but if not, another day. All right, here's the thing. FRQ2, some dumb word problem. Hate word problems. I hate them, and I'm a math teacher, okay? I know you're going to look at this, and you're going to start to just taking a glance at this page, it's annoying, right? Most of us that are not like super duper math people, it's too many words, right? Too many words. What we know, though, is FRQ2 is going to be a word problem, and you're going to pull the same things out every time, and that is 2 ordered pairs. Okay, a team of scientists began studying a population of white-tailed deer in a large wooded area in 2005. Okay, fine, great, deer. 2007, which they're calling t equals 2, year 2, time 2, there were 31 deer. In 2020, year 15, t's time is 15, there are 136 deer. I know it's kind of hard to read all these. The number of white-tailed deer can be modeled by this. So, and then it says d of t is the number of white-tailed deer, t is time in years, okay? So first thing is this. I should be able to find an ordered pair, 2 ordered pairs somewhere in that word problem. Every single time you get to FRQ2, that's what you're going to look for. So I see time or input or x is 2. 31 is the population of deer. That's my y value or d of t. And then 15, 136. So you know now, going forward, FRQ2, find the 2 ordered pairs. Really, the only other thing you need out of there is this. You have to be able to look at that, and it's hard to read because it's not printed very well, and know, is that a linear equation? Is it a quadratic? What is it? This is exponential, and it's hard to see it, but that exponent is a t. So it's saying d of t equals ab to the power of t. Anytime your exponent is a letter, it's exponential. If the exponent was a 2, it would be a quadratic. A 3 would be a cubic, okay? But a letter is exponential. That's what we need. All right. Use the given data to write 2 equations. This is always the same questions, different numbers in here because the questions are different, but the same exact questions. Use the data to write 2 equations that can be used to find A and B. So we're going to write 2 equations, and then for part 2, we'll actually find A and B, okay? Guys, all this is take those 2 ordered pairs and plug them into the equation they gave you. So remember, this is t and d of t. So it's just a, b, sorry, let me write it differently. 31 equals a times b to the second. I plugged in y, I plugged in x. There's one equation. The other equation would be 136 equals a, b to the 15. There, you got a point. Easy, right? Do we get that? Anybody listening or understanding? Rami, did that make sense? Right? You just take the 2 ordered pairs and plug them in. Remember, this is t, this is d of t. Right? T, d of t. It said it right here in case you missed it. Right? So there's my equations. How do I find these 2? Well, here's where we really pray hard to the math gods that we get a specific type of question. If you happen to look ahead at this problem, A2 is all of this work. If we don't get a specific type of problem, we got a good problem here. I promise you, I will another day show you how to do this by hand, this problem, but we don't have to do this by hand. The only time we have to do the work I just showed you for this question is if one of these inputs are 0 and this is a log. Like there's so many thousands of combinations of numbers and equations they could give us. We are going to pray that we don't get a log with one of these being a 0. If you do, the shortcut method won't work and you'll have to do the long method. We will talk about that another day. This is not that problem. For this, we're going to get to do the shortcut. So I'm going to clear my RAM again really quick. Guys, this is a graphing calculator problem. Think about how the calculator can help you. You know, we just did one where we could type the equation into y equals and look at the graph and that kind of thing to look at the end behavior. Well, we don't have the equation yet. That's what we want. We want the A and B so you could plug it into the equation if you wanted to. But what we have is 2 ordered pairs. Anytime we have ordered pairs, we would go to stat, enter. Think about all the table of values you guys have typed in there. X's go in L1, Y's go in L2. We just have 2. As long as you have 2 points, you have a table of values. So you are typing in 2, 15. I can't believe I'm looking at people in this class that are not doing this stuff with us. It's crazy to me. Okay, so I put my X's and my Y's in. And again, this is the stuff you have to know how to do. What button do I press next? Stat. So try to have it come back to you. Stat, over to calc, and then you have to pick what type it is. We know that it's exponential. Look for it. Look for exponential. Hi. Find exponential. You don't have to, like, when we did these problems, like, we were in the section of exponential functions. We just kind of had it memorized at that point, and I'm just scrolling through. We knew exponential was at 0. You don't have to memorize that. You can scroll through your calculator and find which type of regression you want. We want exponential, that's 0. Enter. Do we need to store it? You may not know if you need to, but as I've been telling you guys forever, it takes 2 seconds to store it. You don't know. I'll give you a hint. We will need to store it, but who cares? Alpha trace enter. By doing it every time, you won't forget how to when it comes time for it to be required. Enter. There's your A and B. Nice and easy. So we put our table of values, which happened just to be 2 sets of numbers, and we plugged it in to our calculator. And how do I know what to round to? Your teacher has told you all year. There's nowhere on this test that's going to tell you what to round to. You have to know to round to 3 places correctly. If your third digit is a 0, you can either add it on or leave it. Okay, so if that final number is a 0, feel free to leave it off or put it. Either way, you would get the point. Okay, so notice it didn't say write the model. It just asked for A and B, and A2 will always be that question. You do not need to plug it into this, but that's what it would be used for. Now we have a model. Because you saved it, my darlings, it's in your y equals. You could look at the graph, which we'll look at in a minute. You could look at the table of values when it stops graphing. You could look at the table of values and pull any more information off, and I'll show you how we'll use that, okay? All right, on to the next. Use the given data to find the AROC. We've been talking about AROC all week, all year. Here it is again. We want the AROC from year 2 to year 15. Decimal answer, show the computations. So when you see show the computations, notice it didn't say that for A2. I told you there are times, we'll go over that another day, when you do have to do the computations by hand, but it's not requiring you to. When it asks for the computations, it doesn't mean you can't use your calculator. It simply means that you just have to show a little bit of what your work is. Here's what I mean. We've been talking all week, again, about AROC, which is your change in Y over your change in X, okay? You already wrote the ordered pairs. They're somewhere. Jaden, are you awake? Jaden, I'm sorry. You already wrote your ordered pairs. Can I change the order of my variables here? No, we've talked about that all week too. So 136 minus 31. This is what they mean by computations. Show what you're actually putting in your calculator, okay? Obviously, this part, to get your next part, you can put in your calculator. So I do 136 minus 31 right in my calculator, and I get 105, 13. That can go right in your calculator, and then you will round that to or 3 decimal places. Okay? So what we just found is the average rate of change. It's not good enough that we just know the average rate of change. Like, we all know our slope formula. I don't expect any of you to get that wrong. But what this next question is doing is making sure you understand what you just found. What did we just do? Okay? So before we even get to that, just understand what we just found. On average, each year, our white-tailed deer, or whatever they're talking about in whatever word problem, is increasing by 8.077 deer per year. That's what this is saying. We're increasing. As X increases, Y increases, which you could kind of see already, right, from your ordered pair. Year 2, year 15, 31, 136, we're increasing, okay? So let's see what this is asking. Use the AROC that we just found to estimate the number of white-tailed deer in the wooded area for T equals 19 years. Show the computations that led to your answer. Now, you could go into your table of values and go to 19 and get what the model would predict for us given this information for year 19. But the show the computations means they want to see that you understand how this number can be used to find that. So really kind of clever math here, in my opinion. But, you know, I geek out on this stuff. So look at what we already have. We have year 2 and we have year 15. So I'm going to start with year 15 because it's closer to year 19. In year 15, I had 136 deer, right? How many years later are they asking us to make a prediction? Yeah, how many years after this number, right? So 4, right? This was year 15. So 4 years later, I'm going to have more than this, so I'm going to add. How many more each year? This many each year. So I'm really doing 8.07 plus 8.077 4 times, or let's make it a little shorter. This is what they're looking for. Use the AROC. It even said that. Use the AROC to predict something in the future. So that is showing that you understand. Each year, so 4 added on to this one, I'm going to have approximately that many more deer. So you do that math in your calculator. This is the computations we are speaking of. And you're going to take this one step further. You're going to answer the question, estimate the number of white-tailed deer. We don't have a decimal number of white-tailed deer. So when we graded this last summer, we would, as the graders, we would accept, you could write 168 deer or 169 deer. So we would accept either one. So you're going to show your computations. You'll get a decimal, because you're working with a decimal, and then you're going to give, so that would mean 168 or 169 deer. Okay? Like I said, that question will be the same every FRQ2. You know exactly, especially when we get to our 4th one that we practice, FRQ2, that you are going to know exactly what to do. We didn't have this benefit last year. We didn't know what the FRQs were going to be. Now we do. Okay? This one is tricky. Okay? Remember I told you, I will tell you where you should 100% get your points and where we're going to have to fight for a point or two here and there. This one is a little bit trickier. It's because of the wording. And this particular FRQ2 is not my favorite. The one you're going to take in your mock exam on Friday is a lot clearer, but bottom line is they're asking the same things in every B3 of all of these. Okay, so let me just kind of read it real fast and then I'll try to sum it up for you in my own words. Consider the values that result from using the AROC in 1 to estimate the number of white-tailed deer in the wooded area for T equals P years. So that was at 8.077. So back to that. We're still on that, I should say. And P is between 2 and 15. That's coming from this. Are the estimates less than or greater than the number of white deer predicted by the model D at time T equals P years? Explain your reasoning. Okay. All of this is asking. So this is where we're going to go back to the calculator. What this is asking is, are our AROCs greater or less than, let me see, the model? In this, what's tricky about this particular one is it doesn't say in the years past year 15. I feel like that's an error with this question. What you will always see is very similar wording, and it'll say, as we go past our biggest number, in this case 15, if P is greater than 15, what are we going to see? Is our population going to increase or decrease, and why? And there's something particular they're looking for in this question. So let's go back to what the model looks like, the graph. And I told you we would look at it again in a second. And you can kind of see there's a little piece of it in the corner there. I need to move my window to the left, so we would change our X min to -50. Something, -40, remember we talked about that ad nauseum, how many different ways you could change that. But you want to be able to see the graph, okay? So I'm looking at this graph and it makes sense to me. As X's increase, Y's increase, correct? And we already talked about that, how as time goes on, the deer are predicted to increase and modeled by this graph. Remember, this is a model. But what they're looking for is this. This is the key word. This is one of the benefits of me being a grader on this, is that I know exactly what will get you the point and what won't. This graph is concave what? Concave up or down? Lily, concave up or down? Up. And there's this piece of information that we have threaded through the whole year that we've talked about with concavity, and that is how it affects your rate, your AROC, your rate of change. Remember, I taught you a word to remember. Concave down, your AROC is decreasing. Down, decreasing. Concave up, our AROC is increasing, okay? Which should make sense. As the time goes on, our population is increasing. So I'm not going to write out the whole explanation again for time's sake, and remember, when you have to write a whole paragraph of stuff, and I'm going to read it in a second while you guys start writing, when you have to write, this doesn't have to be exactly how I wrote it. Grammar doesn't matter. Spelling doesn't matter. What they want us to talk about in this question is how our concavity and our AROC relates to what the question is, okay? So because the graph is concave up, our rate of change is increasing. And again, I will explain this question better when we have a better question, okay? When you do the mock exam, you know you're going to have to talk about concavity and how it relates to the AROC on this question. And when I get to go over it with you next week and we go through those, I will come back and do a much better job of explaining this question, okay? Unfortunately, this is not the best FRQ2 question. There's something it's missing that's very specific that helps us answer it. So just for right now, I want you to take away the concavity. Remember, concave up is AROC is increasing, concave down, decreasing. Those are in your multiple choice questions at least 2 or 3 times, knowing that fact, concavity, and how it relates to AROC. So that's a good review of that, okay? And there's one last question on here, and I love this question. I don't even think it's something we've really touched on, but it really makes sense mathematically. Who was that? Oh, okay. He's probably because I have that. Oh, he needs you. Okay. So you guys, I have a meeting at 10 o'clock, so that somebody might be coming for that last minute of class to cover you guys while I go. So that's what I thought that was. So we have time. Good, we're fine. Okay. So guys, if you didn't finish writing that, I'll put it back up in a second. I want to make sure I get to that very last part of the FRQ. I think it's a really, really great question. And again, it's going to be the same question every time you see FRQ2. For which t-value, 8 or 23? So new t-values, not our 2 and 15, different ones, 8 and 23, should the team of scientists have more confidence in when using this model? So they can plug an 8 in or plug a 23 in into the equation. They could go to the table of values and get the population that's predicted for year 8 or year 23. One of those they should have more confidence in the other. And it's almost like a common sense question, okay? And I'm not saying that to insult you if you don't understand it, because it took me a minute to kind of understand it as well. Between 8 years and 23 years, and remember, this is real. This is actual data. This is what they actually observed. This is true data. Year 2, 31 deer. Year 15, 136 deer. Anything else is a prediction based on that actual data, right? We used our math skills and we came up with a way to predict. So which of these should we have more confidence in, year 8 or year 23? Well, 8 is actually in between these 2 years, right? 8 is in the interval of time that we have real data for. We know that between year 2 and 15, we know for a fact that our deer increased. We don't really know what happens after year 15. We can guess, educated guess, based on the knowledge that we popped into our calculator, but it is a educated guess, right? There could be some kind of parasite or something that overtakes the white-tailed deer population. I don't know, guys. They could have their own COVID situation. It wipes out a bunch of, I don't know. But 23, it's just a guess. So the way, again, spelling doesn't matter, grammar doesn't matter. What we're looking for is answering the question. Scientists should have more confidence in t equals 8 because t equals 8 is within the interval of dates. I don't really like how I word that. In the interval of time of 2 to 15. T equals 23 is outside this interval, and we do not have any information regarding that interval of time. Okay, so part C, they're going to give you 2 years. What makes more sense and why? Okay, these FRQ1 and FRQ2 are 2 FRQs you can 100% get your points. We are going to practice more and more, and now you're not going to look at this like, oh my God, this is a foreign language, I'm just going to drop it. Now, because I have time, I'm going to tell you a little trick, a little tip. When you do these 2 FRQs, you have 30 minutes to do FRQ1 and FRQ2, then time's up, you're on to FRQ3 and 4 for another 30 minutes, calculator's gone. You don't have your calculator anymore, but you do have your booklet. And all 4 FRQs are written in the same booklet, okay? you are allowed, it's not against the rules, to go back to FRQ 1 and 2 and finish them if you have time. Remember, you still only have that 30 minutes. You just won't have your calculator. So you wouldn't be able to go back and do like the or maybe you could do that by hand. But if you didn't finish writing a sentence here and you wanted to go back and finish that sentence or something, you could do that in your FRQ 3 and 4 time, okay? But what we want to really practice doing, and that's what the mock exam is going to be so great for, is feeling the feels of that 15 minutes. 15 minutes. I'm getting tired. I'm on FRQ 3. I'm exhausted. I've been sitting here for 3 hours doing math. I'm doing FRQ 4. And learning how to kind of pace ourselves and know where can I get those points for sure, and maybe do I need to save time and not write a paragraph and get to the part that I can do quickly. So that's the things we're going to be working on in here. Okay? Show of hands, do we feel better about FRQ 1 and 2? Okay, thank you. All right, so we're going to keep practicing. And we're almost out of time now, so I'm going to end the recording. But we will do FRQ 3 and 4 tomorrow, and then we have the mock